The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees.
Well, good evening, everybody. This is always a tough time slot to be competing against dinners in Philadelphia, one of the great dining cities in the United States, and of course cold beer. But we'll try to do our best to keep you entertained and hopefully give you some information on this hot topic, alternative cementitious materials. The purpose of my talk really is to try to give you an overview of what ACI is doing in this regard, and it basically focuses on the activities of this ITG-10. And so I'm going to try to give you a summary. I'm not going to try to delve into the document in great depth, but try to give you some overview of what we've been doing and maybe pull out a few things that have evolved from that discussion and use them as discussion points. I do want to first acknowledge the membership of the ITG shown here. I won't read them all off, but you can see them there. They've all put in quite a bit of effort to get this document to the point of where it's at. So I'm going to give you some background on how this formed and how we got to where we're at today. A very brief overview of the document, as I said, and then just try to pull out some of these, I guess I would call them interesting points. I'm not sure they're necessarily key points. In many cases they are, but some of the interesting points of conversation that we had regarding this topic. So how did we get here? Well, things started back in September of 12 at the Strategic Development Council, the SDC, which is another arm of the ACI. And this particular field of alternative cementitious materials was identified as an industry critical technology, which means it had the blessing of SDC to move forward and try to take actions to start implementing these materials and getting them out into the construction world. One of the steps they took to get this implementation going is to form an ATI, which is an Accelerated Technology Implementation Team. There's a lot of acronyms in this world, so this is another one of them. And one of the things that the ATI decided to do was to form an ITG. So the SDC formed the ATI to form an ITG. And the ITG is actually a tool that ACI has used in the past for other technologies to get them kind of jump-started, if you will. And the idea is to form a small group of people to come together and write a document that's going to kind of serve as the basis for helping to implement that technology. The ITG first met in September of 13. We've kind of went up and down and around in some different directions through this process. As it turns out, this particular area was indeed a hot topic. And we had initially a lot of people involved in this ITG activity, which is kind of unusual. And the phrase got used quite a bit that this ITG is different from previous ITGs. And it was. We had a lot of people involved. We had, I think, close to 30 members at one point trying to pull this document together. And the idea of an ITG is to try to move quickly to get a document out and get something moving. And with 30 people, all of you are ACI members, and you understand how 30 people around the table can kind of slow things down. One of the things that we had a lot of discussion on is what should this document be? The document started out as being a user guide, but as we started going through this process and pulling information together, it became very obvious that there wasn't a lot of information out there. So we started looking at trying to put together a user's guide, which in essence means something for the practitioner. There really wasn't a lot to draw from, and what we really started to find is that there's really a lot of needs that need to be addressed to move this technology forward. And so the document then kind of evolved more into an implementation guide. What do we really see as kind of the hurdles, if you will, to getting this material implemented? So the document then, we do try to stress the use in the document. We talk about some individual technologies, and I'll summarize those here in a moment. We'll talk about material selection. What are these materials exceptional at or good at compared to Portland cement concrete? And we try to provide some case studies of where these materials have been used in actual construction to give, again, kind of the user or the practitioner some sense of what can you do with this or what has been done with this. But a lot of the document really focuses on the issues of barriers, and we also try to identify some paths to implementation. I think the meat of the document falls into this area of identifying barriers and paths. The outline of the document is shown here, and again I won't read it off to you, but you can see kind of the standard chapters we have in an ACI document, introduction and scope and notations and so on. Then we start talking in general about properties that we really talk about when we're trying to evaluate these materials, particularly when we try to compare them to Portland cement concrete, which is what we're all going to try to do because we know Portland cement concrete, so we always ask the question, what's different, what's the same, those types of things. And then we reviewed the key technologies that we were aware of in Chapter 4, and then Chapter 5 and Chapter 6, and I guess to an extent Chapter 7, in my opinion, is kind of the meat of the document, where we really look at the whole issue of, number one, first the testing requirements that we need to be able to work with these materials and specify these materials. And then number 6, we really went in to try to look at the design codes. Where are the holes or where are the hurdles within the design codes that are keeping these materials from being implemented? And then we tried to, in Chapter 7, provide a roadmap for how to attack some of these hurdles and how to really start trying to get these materials implemented. We then went through a couple different iterations, and we went back and said, okay, what we really also want to do is we don't want to lose our original point, which was to talk to the users. And so we came and put together the Chapter 8, which is the practitioner's guide. And the intent there, again, is there's not a lot of necessarily hard information that we can point to say do this or don't do that. But what we can do is try to provide the practitioner with, if you will, a list of questions that they should be asking or the things they should be thinking about as they start trying to use these materials. And we try to capture that in the practitioner's guide, along with some case studies of where these materials have been used. So the materials that we talk about in the document are shown here on the screen, and some of these are probably familiar to you, such as calcium aluminate cement, calcium sulfoaluminate cements, carbonated calcium silicate cements. We tried to figure out a way to try to break these into groups, as you can see here. So we call them those that are clinkered alternative cements, those that are non-clinkered, and then those that are formed from calcining of materials. So in the calcining category, we really have the magnesium oxide, magnesium phosphate type of products. And then in non-clinkered are basically the alkali activated materials, activated fly ash slag, recycled glass, and supersulfated cements. Some of the discussion points, I guess, to jump right into those. One of the first things that we had a discussion about is what are we going to call these things? We were handed the name alternative cementitious materials, and we've been using that up until about 6 hours ago. And there's a lot of issue with what did cementitious mean. Okay, to a lot of people that means a hydration reaction. Whether it's true or not, that is a connotation that some people take away from it. What we really wanted to communicate was the obvious fact, which is that these are not Portland cements. But it's kind of hard to just come out and say these are not Portland cements. So I think in the end that's pretty much what we did. Some of these are hydraulic cements, some of these are non-hydraulic cements. So it was really kind of tough to really try to understand how to describe these. And we ended up using the term alternative cement. And so we're moving the document forward using the term alternative cement rather than alternative cementitious material. And the definition that we came up with is shown here on the screen. An alternative cement, an inorganic cement that may be used as a complete replacement for Portland or blended hydraulic cements and is not covered by applicable specifications for Portland cement or blended hydraulic cement, which again is a long way to say it's not Portland cement. Okay, I admit it, but that's what we ended up with. And as you start going through the process of trying to describe these things and all the various things that get thrown up, all the various questions that get thrown up, what came out of it is this lowest common denominator that you see before you. A couple key points that we wanted to put into the discussion for the definition. An alternative cement or cement blend may provide better performance than can be achieved with Portland or blended hydraulic cement in some applications. And that's a key point. One of the things about these materials is in many cases they do provide performance that we simply cannot get with Portland cement. But that's not always the case, so we went on further. And however, an alternative cement may not perform adequately as a replacement for Portland or blended hydraulic cement in every application. And that's another key point, is you can't necessarily use these materials everywhere. So again, we're trying to capture this in the discussion. In some cases, alternative cements may also be used in combination with Portland or blended hydraulic cements, which was another issue that we tried to address because many times these materials are used with Portland cement blends. So again, this definition, we tried to distill down many conversations and try to get it captured into a single little document, a single little statement here. And this is the definition that we'll be moving forward to tack with the document. There's another point of confusion, and that's the second half of the slide down here, which is alternative supplementary cementitious materials. Okay, ASTM has come up with a guide for alternative supplementary cementitious materials, which are basically materials that don't meet C618, C989, or C1240. And there's some confusion about an alternative cement or an alternative cementitious material versus an alternative supplementary cementitious material. And in the case of the latter, the supplementary material, the sense is that's intended to be used with a Portland cement. Just like we use fly ash as an additive with Portland cement, we use these alternative supplementary cementitious materials as an additive. They don't stand alone as a cementitious system by themselves. They're not necessarily used as a cementitious system by themselves. However, some of the materials that do end up in the report as an alternative cement could be used as an alternative supplementary cementitious material. So there's still some little bit of gray area there, and I think we need to do some more work trying to sharpen up all these definitions, not only within ACI but also within ASTM, to more clearly try to articulate this. But that was another large section of conversation pertaining to the name. Another thing that came up is that these technologies need to be differentiated based upon their degree of maturity. There's a number of these materials that are out there, they're being delivered today and they're being used today and they're being placed today and structures are being built with them. There's a number of these materials that are in the starting blocks, so to speak. They haven't necessarily been used, but they're pretty darn close to being able to get used. And there's some of these that are still in the lab. They're still just being developed and they're not out there ready to be used yet. This is obviously somewhat of a matter of your perception. I think some of those people who have the materials in the lab think they are ready for use. And there are probably other materials that are out there being used that maybe people don't have the confidence in and they think maybe they should still be in the lab. So there is some element there of the eye of the beholder, if you will. But we tried to, especially when we started getting into the practitioners type of discussion, we really tried to focus then just on the materials that are currently being sold as products and being used in construction. So some of the materials kind of dropped off. For example, activated glass. Activated glass is something that, yeah, it's been done in the lab and we've made geopolymers with it and so on and so forth, but it really has not made it into prime time, so to speak, as a deliverable material. Test methods. This was a huge issue. And in my opinion, I think it's probably the key issue with these materials. Applicable test methods do not, I put in parentheses here, necessarily exist. The existing tests that we have were designed for ordinary Portland cement concrete. And I think many of us would argue, I certainly would argue, that in many cases they don't work very well for that. Particularly when it comes to durability tests, we have a lot of tests that we use that they're not that good a test. And so now we're going to take a test that maybe has a marginal performance history with ordinary Portland cement and now apply it to these new materials that we don't know very much about. And so I think there's a real issue there. And when we start just blindly taking tests and applying them and saying, well, our material passed that test. Well, so what? You know, that test wasn't designed for your material. And it hasn't been proven that that test does work with your material. Now, it may very well be that that test will work with your material and everything is wonderful, but we don't have the experience yet to say that that is the case. And we need to be very aware of that when we start looking at test results from these various materials, really start thinking about what the test is telling us and is it really giving us the assurance that we think we are getting from that test. To me, I think the testing is really one of the key things that we really need to focus on in the short term. We really need to start looking at all the various tests that are being applied and, first of all, making them so they, at least on paper, do apply to these materials. And then secondly, verifying that, in fact, they do give us the information that we're seeking. Specifications, performance versus prescriptive. We had a lot of conversations about this. We were, in terms of codes and specifications, one of the things we talked around is, can we put out basically a straw man performance specification for these materials? Well, then we start having the same old conversation that we're having with the Portland cement when it comes to performance specs. What's performance? And how are you going to measure it? Particularly if we don't have the right tests. How are we going to measure that performance? Performance specifications have not been widely embraced in the Portland cement world. And there's no reason to suspect they're going to be any more widely embraced in the alternative cement world. However, we have a very distinct advantage when it comes to alternative cements, and that is that we're starting out with a blank piece of paper. So we can start working in the performance world right from day one and start formulating our specifications from a performance perspective right from day one. In the Portland cement world, we've got 100 years of baggage that we're carrying with us. All this information that we think we know or that we're basing our design on, and we're trying to then to shoehorn a performance into that world, and it's a very tough go. So I think performance specifications are probably the way to move forward with these materials. We're going to have the same challenges, but I think we have a couple things in our advantage when it comes to actually trying to implement a performance spec. Increased use and implementation is not just the responsibility of the producers. This is another point, especially when we start looking at codes and specifications. Code writing agencies will say, well, just give me the information I need to design with this, and then I will go ahead and write a code around that. And so then the producer says, well, what information do you need? And he's like, I don't know. You just give it to me, and I'll tell you if it's right. So it's this circular argument back and forth about, well, what do you want to know? And then even if you do get to the point of what do you want to know, okay, then you're back to the other problem, well, how am I going to measure it? I don't have the right test necessarily to measure it. So there's definitely a need for more data. I mean, clearly there's a need for more data, particularly as it comes to designing of these materials. But as a code writing agency, we need to accompany that with a plan. We need to go to the producers and say, here's the type of information we need, and have a plan for how to get that information. It isn't just throwing it back in their face and saying, figure it out. And so we tried to, in essence, start that conversation in the document, providing a clear roadmap for implementation. And that's a two-way street. It's going to be from the producer's perspective, and it's going to be from the specifier's perspective. We have to work together and figure out how to get to this point where we know how to design with these materials. And we're going to probably end up utilizing some tests that are not standard tests, because some of these materials are just tests that we don't have materials for, and we're going to get information that maybe doesn't come from a standard ASTM test. Doesn't mean the information is wrong. It's just that we don't have a standard test for it. So we're going to have to learn to interpret the test as well as interpreting the results of the test to understand if it's really giving us what we think we need to design with this material. I mentioned the baggage. The current specifications that we're dealing with, I mean, the Portland cement concrete has been around for 100 plus years, and we've got a lot of data, a lot of field experience, a lot of laboratory experience, and we need to do similar with alternative cements, but we can't necessarily wait 100 years. Okay, I don't think anyone who's interested in this area wants to wait the same period of time it took us to get to where we're at with concrete, Portland cement concrete, to be the same place with alternative cements. We're going to have a new thinking on how we get data. And we're going to have to start thinking about things in a different form. Functional performance, for example. How does it function when we compare it to a Portland cement concrete? Do we get a comparable performance? So it's not just an absolute number that we get, but when we compare this one to a Portland cement, how does it perform? And we need to rely on material science. And this is one of my soapbox items, that we're not dealing with, even in the Portland cement concrete world today, we're not dealing with the kind of materials we dealt with 30 or 40 years ago. These materials are very exotic. We have a lot of mixtures of materials, a lot of mixtures of chemicals, a lot of things going on, a lot of different processes for treating those materials. And to be perfectly honest with you, I'm not sure that we have the right people in the room to make those decisions. Unfortunately, I would assume that probably most of you are civil engineers by training. And if you're like every other civil engineer I've ever met at the university, you chose civil engineering largely because you hate chemistry. And so that's how you got into civil engineering. And so now you're going to go off and you're going to start working with these exotic materials without having any background. We need to start relying on materials engineers. We need to start producing materials engineers in our educational program, but we need to start relying on materials engineers in our industry. And I'll give you one example that I like to use, and that's one of these things here. Where is it? So how did we get to the point where we got, in this little device right here, all the power that we have? We have a full computer in here. We have all these activities. This is a Radio Shack ad from 1991, and pretty much everything, with a couple exceptions, pretty much everything in this ad you can do with this thing right here now. So how did we get there? Well, yeah, we had some smart computer science people, we had some smart electrical engineers, but we had some smart materials engineers who figured out how to make the materials to make this thing. You know, just start with the glass, the Gorilla Glass in the surface. That was materials engineering. Every other industry uses materials engineers to improve their product. If you're going to build a new engine, and if you're working for an auto company, if you're a mechanical engineer, the first thing you do is you go and consult a metallurgist to figure out how to make the material you're going to use to make the engine out of. Okay, we don't do that in our industry. And that's a real weakness in our industry. We need to start relying on materials engineers, because as we move forward with these new materials, understanding the material science is going to be key to success for implementation. So in terms of gap analysis, test methods, I think, are the first thing we need to tackle. We really need to start figuring out how to get in there and get these test methods so they apply to these materials. We try to identify conceptually some changes that are needed. We can't go through every ASTM and tell you everything that should be changed in every document, but conceptually we try to give you the idea of where do we need to go in order to start changing these test methods. We don't have the processes in place to make these changes. ASTM is just as resistant, we'll say, to change as is ACI. And so how are we going to implement these changes? It's going to take pretty much in every case, it's going to take a champion. It's going to take someone who's going to go to the committee at ACM who writes that test method and say, I want to adopt this test method for use with insert material here, and make those changes. And that means everybody in this room, everybody involved in this business is going to have to play some role in trying to get those test methods changed, because one person or even a handful of people can't do it. Design specifications, as I said previously, we need to have a path to implementation. We need to lay out what information do we need to get and how are we going to get it. It just can't just be give it to me and I'll know it when I see it. We have to have a path to get there. And we can't, as I said previously, wait 100 years, because that's how we got to where we're at now. 100 years of experience with Portland cement concrete. We can't repeat that process. So there's a number of different things that we identify in the document, different properties that we try to measure, different things that we have test methods for. The ones that I put on the asterisk by are ones that right now the tests we have are probably perfectly fine. When it comes to chemical composition, particle size, density, heat of hydration, we could use our existing tests and there's really going to be no issue. And we are using those tests. There are other tests, for example, I have highlighted here strength, ACM C39. We all mix cylinders and we break them, okay? We look at the compression strength. Well, great, and there's nothing wrong with that. We need that piece of information. But if you read the C39, it doesn't apply to anything other than hydraulic cements. So if we take that test method and apply it to the way it's written, we're not applying it correctly. So we have to make at least a simple change to say it applies to things other than hydraulic cements, concrete. And then you start looking at it further to give you very prescriptive methods for how to cure your samples if you're going to do the test. Well, a lot of these materials, we don't cure them that way, especially if you want to get your optimal strength out of it. So we need to have changes down at that level. We're actually going to start talking about things like curing and how we're going to prepare these samples. And they need to be addressed in these test methods. There's a whole list of different things that we need to know and we need to develop tests for. A lot of design information is all listed here. And all these things, we need to figure out a path or how to get this information for these various materials. And when it comes to design, again, more materials, things that a code rating agency would want to know about. I highlighted bond there because that's for the reinforced concrete. Of course, that's one of the things that's very important is to measure bond. Well, if you go look at the test for bond, A944, it's a pretty simple test. First of all, it has a caveat in there that says that the results of this test can't be used for design. Okay. So I don't know what we're going to do with that test. But then you make a block of concrete, and the only thing they tell you about the concrete is it has to have a strength of 31 to 38 MPa, period. That's it. That's all they tell you. And then you stick your rebar in there and you let it set, and then you pull it out, and that's your bond. But you can't use that number for design. It's a very simple thing. It's a very basic thing when it comes to design. It's understanding the bond. And we don't have even a good process for getting that number for Portland cement concrete. How are we going to get it for these other materials? So again, there's a role here for ACI and the various committees to look at how to get that done. Field data. If I were to give advice to a producer of this material, I would say start today and put material in the field and start getting field data. Even if you're just going to go out and literally out in a field somewhere and put test blocks, go do it, okay? Because we still need 5-year data, we still need 10-year data, and I got news for you, it takes 10 years to get 10-year data. So start today, all right? Start getting that information today, because ultimately we're going to need that information. And a lot of the producers aren't necessarily doing that. Some of them are, but a lot of them aren't doing that. And that's just one thing, that's a very simple thing to do. It's a very low cost thing to do. Just make some test blocks and start measuring the long-term durability. We need to look at various placements. I think there's a lot of low-risk placements where we could use these materials and learn about how to work with these materials. There's a couple of case studies in the document where we show where these materials have been used. Obviously, we're not going to go start building 80-story buildings out of some of these materials, but there's a lot of things that we can do, and we should start doing that. There's roles for agencies like Federal Highways and these agencies to maybe take the lead on encouraging some of these projects to occur. And of course, there's always the risk factor. What happens when it goes south? And someone's going to have to stand up and take that risk. And so, you know, federal agencies, those types of groups are the ones that are best positioned to assume that risk. So we're making progress. The status of the document is that as of noon today, the document has cleared the committee. It's been approved. It's going to TAC for their review, and I'm sure very, very few revisions. You know, TAC just never has really much to say about these types of things. So I'm expecting 3 or 4 comments, and then we'll be done with it. So we'll get the TAC review and revisions back, and then hopefully get those implemented, and it would be my dream that this thing is done and ready for press after the Detroit meeting. So it depends on how quickly TAC gets their comments back and how many of them we can address in that amount of time. We're going to recommend to TAC that once this document is done, the ITG is over. Okay, it ends, it's done. So then the question is, what comes next? We're going to recommend to TAC that a committee be formed to look at alternative cementitious materials, alternative cements, whichever name we decide to adopt, and continue the work that we've already started here. Take this document, convert it to a state-of-the-art document, start looking at maybe more detailed documents on the individual technologies, things of that nature. Maybe start looking at a more robust or more developed performance specification model that we could use. So there's a number of activities that we can follow on with this activity.